War is changing, not with bigger bombs or faster jets, but with intelligence. Artificial intelligence. Across the world, militaries are quietly rewriting the rulebook of warfare. Machines are learning to fight, to decide, to survive, without a human ever touching the controls. And today, we're diving into the front lines of that transformation. The machines redefining the future battlefield, from the AI-driven fighter jet XBAT, to the autonomous tank Abrams X, to the silent assassins of the sea. Welcome to Next Tech, where we decode the technology shaping tomorrow's wars. Let's start in the sky, where Shield AI's XBAT is rewriting what air superiority means. At first glance, it looks like a fighter jet, stealthy, sleek, built for speed. But here's the twist. There's no pilot, no cockpit, no runway. XBAT is a jet-powered, vertical takeoff and landing combat aircraft, a fighter-class drone that can take off from a ship, a highway, even a container trailer, and fly into hostile airspace completely on its own. Powered by a fighter-grade engine, the kind used in F-16s, it can climb above 50,000 feet, hit near supersonic speeds, and travel over 2,000 nautical miles. But the real weapon isn't its missiles. It's the brain inside. That brain is called HiveMind, Shield AI's autonomous flight and combat system. HiveMind doesn't just fly. It thinks. It navigates without GPS, communicates without human input, and makes tactical decisions in real time. Imagine a swarm of XBATs flying ahead of manned fighters, scouting, jamming, striking, while the pilots stay safely behind. It's a loyal wingman concept on steroids. And the reason this matters is simple. Autonomy equals survival. In a future war where communications could be jammed and pilots can't see past the horizon, an aircraft that can think for itself could decide who wins the skies. But here's the catch. Shield AI's vision is still being tested. Integrating full autonomy in a supersonic, VTOL-capable fighter isn't easy. The engineering, the safety, the legal framework, all of it is still in flux. But if XBAT works as promised, it won't just change air combat. It'll change what it means to be a pilot. Now let's drop down to the ground, to the robust MRCV, Israel's answer to autonomous land warfare. It's not science fiction. The robust is already real, a 6x6, medium robotic combat vehicle that can scout, fight, and even destroy enemy armor, without risking a single soldier. Built by Israel's defense industry, Elbit, IAI, Rafael, this machine is designed for multi-mission flexibility. It's got a 30mm cannon, anti-tank missile rails, and a drone launcher on top. Yes, think of it as a battlefield multi-tool. It can lead the charge, draw enemy fire, scout urban streets, or evacuate wounded soldiers, all while a human operator sits safely miles away. And it's not just remote-controlled, it's highly autonomous. The onboard AI handles navigation, terrain analysis, and target recognition. The system decides how to move, when to stop, how to cover itself, like a digital soldier made of steel. The logic behind it is brutal but clear. Future wars will happen in cities, and humans are too fragile for that kind of chaos. MRCV is the beginning of replacing human exposure with robotic persistence. But Israel isn't the only one thinking that way. The UK is building something far smaller, but no less dangerous. Meet Jackal, the world's first electric VTOL drone that can take off like a helicopter, fly like a plane, and kill like a missile. This little monster from the UK firm Flyby Technology recently fired live Thales missiles during testing, proving that even small, electric drones can deliver deadly precision. Here's the genius of Jackal. It's modular. The same aircraft can be fitted with sensors, bombs, or logistics pods, depending on the mission. Need surveillance? It becomes an eye in the sky. Need a strike? Load up 2 lightweight multi-role missiles, and it's ready to hit armor or small boats. Because it's VTOL, Jackal doesn't need an airbase. Soldiers can launch it from trucks, rooftops, even ships, giving armies flexibility they've never had before. Electric power means low noise and fast deployment, but it also means limited range. Batteries can't yet match fuel. Still, for short, precise, and rapid missions, Jackal is a game changer. And the fact that Taiwan ordered 160 of them, that says a lot about where the world is heading. Small, smart, swarming firepower instead of giant fleets of manned jets. But in the world of tanks, the revolution is just as bold. Because the US is testing something that looks like a tank from the future, the Abrams X. Built by General Dynamics, this isn't a simple upgrade. It's a total reinvention of the most feared tank in modern history. The Abrams X is 20% lighter than its predecessor. It runs on a hybrid electric engine, saving half the fuel while adding stealth capability. It can move in silent mode, creeping across terrain using just its electric motors. Inside, the human crew sits deep within the armored hull. The turret above them? Completely unmanned. Controlled through digital displays and 360 degrees cameras. It's like playing a game, except the stakes are life and death. The main gun, a 120mm XM360, fires high-pressure rounds and future programmable munitions. It's paired with an AI co-pilot that detects, tracks, and prioritizes threats automatically. This tank can also deploy drones, link with robotic vehicles, and act as a command node in a manned-unmanned team. That's not theory. That's the future structure of the U.S. Army's next-generation combat network. The Abrams X isn't in full production yet, but its message is clear. The future tank doesn't just crush enemies. It thinks before it fires. Now, if you control the battlefield's electromagnetic spectrum, you control the war. That's where Endural's Pulsar steps in. It's not a gun. It's not a tank. It's a digital weapon. Pulsar is an AI-enabled electronic warfare system, capable of detecting, jamming, and spoofing enemy drones, communications, and radar. It listens to the radio spectrum, identifies signals using machine learning, and can shut them down almost instantly. The system can even locate where those signals are coming from, allowing real-world forces to strike those emitters physically. What makes Pulsar terrifying is its adaptability. It's software-defined, meaning you can update its attack capabilities like an app. A new enemy drone appears with a new signal, update the software, and Pulsar learns how to kill it. There's a man-portable version, a vehicle-mounted one, and even airborne units that can hunt drones mid-air. Think of it as the brain of the electronic battlefield, quietly controlling what the enemy can or can't see, hear, or communicate. And that's not science fiction. It's already in demos with military units, proving that in the next war, software may be more lethal than gunpowder. Let's shift gears from high-tech data wars to brute force protection. The DOKNG MV3 is a Croatian-built electric-tracked robot designed to do one thing: go where humans would die. It's not fast, it's not flashy, but it's built like a tank for the most dangerous jobs: counterterrorism, bomb disposal, hostage rescue, and casualty evacuation under fire. The MV3 is small, under 5 meters long, but can carry up to 8 people behind armored plates made of Armox 500T steel. It's got a 36 kilowatt-hour battery pack, silent electric tracks, and quick-change couplers that can attach shields, cameras, or robotic arms in seconds. It's the kind of machine that rolls straight into a firefight while operators control it from half a kilometer away. This isn't the kind of robot you see in sci-fi. It's here to save lives, not end them. But it proves one thing: even on the ground, autonomy is replacing bravery. The future battlefield won't just be filled with drones. It'll be filled with robotic teammates. Speaking of drones, let's talk about the one that started it all: the MQ-9 Reaper. You've seen it in headlines, in documentaries, in movies. It's the most famous combat drone on the planet, and for good reason. With a wingspan of 66 feet and the ability to stay in the sky for 27 hours straight, the Reaper has become the ultimate hunter. It's powered by a single turboprop engine, flies at 50,000 feet, and carries everything from Hellfire missiles to laser-guided bombs. It's not autonomous. It's flown remotely by crews thousands of miles away, but its presence has defined 2 decades of modern warfare. From Afghanistan to Africa, the Reaper became the U.S. military's iron sword. It can surveil entire cities, track a single vehicle for days, and strike with pinpoint accuracy. Newer versions like the MQ-9B Sky Guardian can even fly through storms, detect other aircraft, and operate safely in civilian airspace. And now, the Reaper is evolving again, with AI-assisted target recognition and manned-unmanned teaming. So, even the original king of drones is preparing to hand the throne to its smarter, more autonomous descendants. But while drones and tanks fight above and below, there's a new kind of weapon rising, one that fires light instead of bullets. Meet Helios, the U.S. Navy's high-energy laser with integrated optical dazzler and surveillance system. This isn't sci-fi anymore. Helios is a real ship-mounted laser, a 60-kilowatt beam of focused light capable of melting drones, blinding sensors, and disabling small boats at the speed of light. There's no recoil, no ammunition, just raw, silent power, drawn straight from the ship's generators. It's mounted directly into Aegis-class warships, integrated with radar systems for instant targeting. One Helios unit can track, lock, and burn multiple threats, again and again, as long as the ship has power. The Navy tested it aboard the USS Preble, successfully taking down airborne targets. But lasers have limits. Bad weather, fog, sea spray, all reduce their effectiveness. And generating enough power to burn through thick armor or missiles is still a challenge. Even so, Helios marks a turning point. It's the first time directed energy weapons have gone from labs to warships, a sign that the future of defense may rely on photons, not projectiles. And that brings us to the final frontier, the ocean depths. While everyone's looking at the sky, some of the most advanced machines on Earth are being built to move underwater. This is where Seacraft's Diver Propulsion Craft, or DPC, comes in, a modular, submersible vehicle designed for special operations. At first glance, it looks like a compact mini-sub, but this isn't a submarine. It's more like an underwater motorbike for commandos. The DPC can operate both on the surface and underwater, switching modes seamlessly. It's powered by quiet electric thrusters that generate over 120 kilograms of thrust, letting divers travel up to 60 kilometers without resurfacing. It's designed for covert insertion, sneaking special forces into enemy harbors or coastal zones unseen. Its hull is made from amagnetic materials, making it nearly invisible to sonar and magnetic sensors. It can even tow cargo or small payload pods behind it, acting as a modular transport for gear, explosives, or supplies. For modern navies, this kind of stealth mobility is priceless. In a world obsessed with air dominance, the DPC reminds us that control of the sea, especially beneath it, still decides wars. Now step back for a moment. Look at all these systems: the AI-driven X-Bat fighter, the robotic MRCV tank, the electric Jackal drone, the hybrid Abrams X, the software-defined Pulsar, the armored MV-3, the enduring MQ-9 Reaper, the laser weapon Helios, and the stealthy Seacraft DPC. They might look unrelated: air, land, sea, space, data, but together they tell one story. The era of human dominance on the battlefield is ending. The next war won't be fought by soldiers with rifles. It'll be fought by networks of intelligent machines, coordinated, autonomous, and lethal. They won't tire. They won't panic. They won't need sleep or food or glory. And that raises a haunting question. When machines start to make decisions in war, what's left for us to decide? Because once autonomy crosses that line, once an algorithm decides who lives and who dies, war stops being human. And yet, it's happening. Right now, every test flight, every prototype, every AI upgrade is pushing us one step closer to a battlefield run by code, not courage. The future of warfare isn't just about firepower. It's about who, or what, pulls the trigger. And the answer might just define the future of humanity itself. Now don't forget to subscribe our channel, hit the like button, and share the video. Stay curious. Stay aware. Because the war of tomorrow has already begun.